Okay, lovely, perfect. Thank you so much. I hope coffee was good. Thank you for coming back to the room. If you'd like to take your seats, please, and we will continue with our next talk. And our next speaker is originally from France, and he's a senior product manager at MathWorks, leading the roadmap and the vision for Polyspace products. He started in 2001 as a quality engineer and a major contributor to the first DO178B qualification kit. Then he piloted the definition of the Polyspace requirements to integrate them into DevOps workflows. He holds a master's degree in fundamental mathematics from the University of Georgia. Let's warmly welcome Alexandre Langenier.
Bonjour. Hello, everyone. Good morning. Very happy and honored to be with you today. My talk today will be about static code analysis and how you can use those techniques to maintain software quality along your development process. So let's first start with a very high-level statement. Nowadays, our lives depends on software. Everywhere you have software. In those landing gears of the airplane, I used to come to Poland. In this electric grid to control the power and distribute the power into your country. In the train, I took from my last visit yesterday to your lovely city. In your car, everywhere. Nowadays, a car, it's more than 20 million lines of code. Yeah, that's a lot. Finance, of course. Medical devices, when you go to the doctor for radiography, MRI, etc., it's all powered by software. And in telecommunication with satellites, and because we are at a Nokia event, in the 5G infrastructure and other telecommunication infrastructure. So with all this stuff, depending on software, you expect the software that control, for example, that landing gear, to be very high quality. But when I say high quality, what does it really mean, in fact? What is software quality about? Any clue on that? Any idea? Someone want to react? How do you measure? How do you control your quality? Yeah. 1 point. It's about? Yeah. And? Yeah. Yeah. So I heard a lot about the first one. One of the key elements of the software quality is, in fact, the functional correctness of your software. Is your software behaving as you expect to do, as it has been defined in requirements, in your specification, in your design of your software? But that's just one piece of the software quality. We have many other pieces you want to potentially focus on when it comes to software quality. Can be performance. Is your software running as fast as is it expected to be running? Is it compatible with the environment the software will be integrated in? Is it usable? Can be perfectly fulfilling its functional requirements, but still being very difficult to use. Is it reliable? The landing gear of the airplane. Is it reliable? Does it have some kind of robustness issue that would make the landing gears, the system that controls the landing gears, not running correctly? Is it secured? Can someone enter into your system to hack some privacy data or whatever, do nasty things? Is it maintainable by the team of those thousands of people working on the same software? And is it portable? Next generation of hardware on which you will plug your software, will it work as expected on that new hardware? So software quality embraces all those kind of categories. Now, how do you test your software? How do you verify that you fulfill those software quality requirements? Please, give me some techniques you are using in your team. Testing, yeah. Testing is often the first one everyone is thinking about. But let me just state that testing is definitely not enough. Here is a small illustration why testing is not enough. So this is the first launch of the Ariane 5 rocket in 1997. As you can imagine, they tested the rocket very extensively, and still it failed. It failed not because it was missing testing, but because the code was not robust enough, and it would not have been possible to ensure that that robustness issue would not happen during that first launch. So testing is not enough. And in fact, it's not enough even for security. When you have those kind of attacks, such the last recent one about OpenSSL. And yeah, critical vulnerability identified a few weeks ago on OpenSSL. And look at the patch. This is the patch that fixes the security vulnerability. Very simple. And this is almost impossible to achieve by testing. So testing is just one piece of controlling your software quality. You can use testing, and there are plenty of techniques about testings. Another one, and this will be the main topic for today, is static code analysis. You also have techniques such as software composition analysis to check the absence or presence of vulnerabilities into your third-party components. And one we would think about that is very obvious for software developers is peer review, code review, when someone is reviewing your code. It's another technique. So static code analysis, for those who don't know that techniques, it's, well, as the name states itself, it's a way to analyze a software program without executing the program. It's like, let's say, the spell checker you would have in Word. But it can be more or less powerful. Do you have any ideas of methods, techniques you can have with static code analysis? When I say static code analysis, what do you think about? Sorry? ICOS. Okay. Other ideas? Okay. So my talk will be useful. So there are plenty of techniques. It spans from coding styles to code proving. So coding styles, what is it about? Well, how do you write your code? Is it that nasty C or C++ code, not indented, several instructions on the same line? Well, if you have some tools that can reindent, warn you about the unwell structure of your code, it's a kind of static code analysis, the most basic one. Another one is compiler warnings. Another one is when you set some naming conventions within your team. It could be code metrics to measure your code complexity, etc. It could be even coding standards. Maybe some of you have heard about CERT-C in terms of security. It can be more advanced tools like linters, bug finders, what we call them. So they can detect hundreds kinds of potential defects within your software. And it can be even code proving. Code proving is a very advanced technique. It's based on formal methods. So it's where I started to work at MathWorks. It's mathematical frameworks that analyze the source code to produce very accurate results. So it checks exhaustively for every statement within your code. And it can ensure that critical security vulnerabilities and robustness defects are present or absent. So it's additional, how to say, evidence that your code is safe and secure. That's the most advanced technique you can use to verify your code statically. So you have all those techniques, you have those quality objectives. Now, when to use which techniques and for which objectives in quality? Well, it depends. For functional correctness, no, it's testing. When you want to test that your software behaves correctly, you will need to write the test. This is where it will match the requirements, the specification, etc. So for performance, that's another story. If you want to test for performance, it's always a nightmare. You have to run on the hardware, you have to find the most tricky use cases to test that the software behave as it was intended to behave in terms of performance. And for that, you can also rely on static code analysis. It can give you some hints about, well, bad coding patterns. If you pass data by copy instead of by reference, well, it will have a huge impact on performance. Could use bug finding, could use even code proving to detect dead branches at runtime, so you can remove them from your code, and it will be smaller when you will have to flash your software within its target. Compatibility, you can use some of these techniques also to check how it integrates into its environment. Usability, it's all about user. So it's human interaction. Even testing automatic in a way you would run automatic test would not work there unless you are using some kind of robot to ensure you guarantee the usability you had. Reliability, it's all about robustness, and for that, many techniques can be applied. Same techniques can be applied for security to check for vulnerabilities within your software. Maintainability, it's about coding standards, code metrics, using well-defined processes to ensure that the next person that will come on the project will be fast up and running on this project. And portability, well, a lot of techniques may apply also to check for portability of your software. So, at Nokia, the software you develop, do you think they are critical? This is a very important question, because this question will drive which techniques in static code analysis, but also that would apply to other verification activities, which kind of static code analysis techniques you will use with regards to your criticity, the criticity of your software. So is your software safety critical? Is the life of someone or a lot of people depending on your software, like an airplane? Is the software security critical? Maybe the bank system at some point. Maybe communication systems are security critical, at least some pieces of them. Are they business critical? If your software fails, does your company lose billions of or millions of euros, dollars, whatever? That's the kind of question you need to answer. And you need to assess the criticality of your software. And it can span from a very uncritical software, and it's perfectly fine. I mean, not all software is critical. If you write some data analytics in MATLAB, Python, whatever, for a side project, it's not critical at all. Maybe it's a bit more critical because you develop a mobile app, a video game, a desktop app. Well, it's up to you to do that effort to determine the criticality of your software. It can be security, safety, business, again. So I put 4 stars for 5G router, but I don't know. You know better than me if it's critical or not. Then, which techniques to apply? Well, if your software is not critical, no need to spend time to run static code analysis. Don't do over quality. Maybe coding style, at least for yourself, to remember 2 hours after you implemented that nasty function, what you did, and being able to review it, at least yourself. But if you start having a software that is a bit more critical, you may want to have more techniques, compiler warnings, naming rules, maybe adding some standards to check for security, for something that could be security a bit critical, and so on, and so on. So it's all about the criticality assessment that will derive which techniques you should use for your development project. So, you define your quality requirements depending on your software criticality. You apply the expected static code analysis techniques with regards to those 2 first inputs, and it will define you software quality objectives, code quality objectives. that you will define for your specific project. It's not for the project of the team that is close to you. It's for your project. So, where do you apply static code analysis? It's a big, vague question, so I will dig into the detail right now. So your project, it can be a couple of C++ files, Python files, MATLAB files, whatever, for doing that data processing analysis. But it can be a bit broader. It can be also a kind of component, your project, that will interact with the team that is seated just close to you. That is another component with other software units, maybe other language. Maybe you are using a third-party library. And maybe your project, in fact, is quite big, and it's many components with thousands of files using these dozens of libraries, maybe running on real-time operating systems or operating system. And when your project is that complex, comes the question, okay, now I need to test. You have plenty of questions to answer with regard to testing that project. And how does it fit also for static code analysis? What do I need to do? What do I need to apply static code analysis? On which component unit? Well, you can apply the techniques on the unit, and usually that in terms of feedback loop, it's the best way to apply it on the unit when the developer is just creating that unit or maintaining or editing the unit. And you can apply many techniques. So here I listed all the techniques that may apply. And we are missing a dimension here, because you would not apply all the techniques depending on the criticality. Doing code proving or bug finding, if your software is not critical, makes no sense. It's just to illustrate that on the unit, you can apply all those techniques, because this is where they are usually the best used. On the component, sometimes it's useless to do compiler warnings, because compiler works at the file level. Maybe the linker would do a couple of warnings, but that's quite unusual. Coding styles, you would have fixed everything at the unit level. So you can restrict the scope of the analysis. And you will search for other kind of issues running the static code analysis at component level. You would search maybe for integration between units, integration issues. Then you may want to apply static code analysis also within the integration of components, because you have other activities to perform, like, I don't know, searching for concurrency issues, things like that, for which you need components and even maybe the operating system that manages the tasks, the entry points of your software. So that's basically the scope of application of static code analysis through a very simple unit file to a complete system that you would like to verify. So, when, during your development process, you think it's relevant to use static code analysis? Any idea? Yes, CI/CD, very good. So just step back a bit and think about the code analysis maturity level. We will define those maturity level depending on how you are using code analysis. It could be the same with testing and other verification techniques. So first level is you are not using static code analysis. It can be fine, no problem. Data analytics, again, no need for static code analysis. No judgment, just do the right thing and don't do over quality, don't do under quality. It's a kind of balance. Can be used once per release. It can also be fine. Just think about the software that goes to that train, for which it takes 5 years to build a train and 1 year to develop the software. Then it's fine to run static code analysis at the end of the project, software project, and eventually iterate. That's fine also. Then you can run it at several milestones during your project. You would think about the critical issues that would be detected by static code analysis. You would add them to the backlog, and so on. Then you can fully automate static code analysis in CI/CD, for example, where you would have critical issues that must be resolved. So you cannot promote the code change if you introduce critical issues. And finally, the highest level of maturity in terms of static code analysis is when you integrate static code analysis from within the development, the code editing, down to the integration of integration branches, for example. And you need to fix all critical issues, it breaks the build, etc. So that's the most advanced way to use static code analysis. None of them is good or bad. It's good or bad to not use the right level of static code analysis depending on your software criticity and your delivery expectation. Do you deliver every day, multiple times a day? Maybe should be level 4. As I said, if you deliver once a year, level 1 might be far enough. Development process. We have plenty of development processes. So when I started at MathWorks 20 years ago, waterfall was the main way of developing software. You have to spend many times writing your requirements, designing your software, implementing it, verification, and bam, at the end, a bug. Well, restart from everything. So it was not really efficient. Still, in the embedded systems, developing complex devices was good enough because software was not as prominent as today. Nowadays, we want to deliver more software more often. We need to move from waterfall to agile. So this is what we have seen in the last decade. Agile means continuously build and test and code analyze your software. And finally, for those delivering software that operates and from the operation you can get input to your software to include into the next delivery of your software, you have that DevSecOps concept that has been raised in the last couple of years. So you may follow one of these development process. Again, no judgment, all are fine as soon as they are fulfilling the requirements of your project. So, today I will speak about continuous static code analysis. You can use static code analysis in kind of DevOps workflows. And when you use it that way, it's easy to extrapolate how to use it in a continuous integration workflow, into a waterfall workflow. Just pick the things that are meaningful with regards to your project development process. So static code analysis does not care about the operations. It's about writing code and checking the code that has been written. So we will discuss only the development part of that DevOps workflow. What it looks like. So it's pretty obvious what I'm presenting there. Usually you have a developer that will check out a branch from integration, release, whatever, main branch, do some kind of code editing. He would pre-qualify his code, doing some testing, maybe some static code analysis, maybe, I don't know, code review. He would push his change for a pull request or whatever you name it to be reviewed by his colleague. Then code will be promoted to integration branch. It would certainly trigger CI pipeline, whatever that would build the software, run the test, performance, functional, maybe robustness test, etc. And hopefully, if you need it, static code analysis. Those pipeline branches would ideally set up quality gates with regards to the quality objective you have defined. And all those results from the build, from the test, from static code analysis should be published into a quality dashboard so your team can constantly monitor the software quality of your project. So what it looks like using static code analysis in that workflow. Well, in the DevOps workflow, you should start, as we seen earlier, using static code analysis within the IDE. That's the most efficient way to find the issues while you are coding. Why it's important? Because it's fresh in your mind when you are developing and you introduce a new error. Don't need necessarily to be the most complicated errors. It can be breaking naming conventions, not following coding standards, etc. If you check it as soon as you code, well, it's not an issue anymore. It's even not promoted into your code repository. So that's really the best way to use static code analysis in very efficient manner. So using that way, it can find and fix defects as soon as code is written. And it provides instant feedback to the developer. It's something that is really interesting. It also enables continuous training of the developer. As soon as you always do the same mistake, at some point, you will learn from that mistake and not doing anymore after that. So you develop your new, very fancy feature, then you are very happy, test is okay, etc. You want to have your change review by your colleague. And that's a good place also to include static code analysis during the code review process. So, well, did your code, seems to be clean within your IDE, so you push it to your code repo, and then in your Gerrit system or in your GitHub review stuff, you would expect to have some kind of pre-qualification testing stuff that would be automatically triggered by the pull request and provide quality feedback in terms of code verification to the developer and to the reviewer. And then they can focus on that kind of quality gate with regard to the code review and comment as they wish together. If it's good development, good in a sense, we don't want to judge, but yeah, you can have the summary of the static code analysis directly within your code review tool. And that's great because part of the code review activity focuses on, let's say, robustness or vulnerabilities within the code. And if you use static code analysis, you can replace these activities by using static code analysis. And the consequence of not focusing on robustness, performance, or whatever, is that you can focus on the algorithm. Is it functionally correct? Maybe that sorting algorithm could be improved, blah, blah, blah. Just focus on where you have the most value there. Let the tool do the nasty job. Well, everything is fine. You agreed that the code change is correct. Then you push the code change to the repo. It should trigger a pipeline that would include the build of your component system, depends how you define it, your pipeline. And part of the verification pipeline should be static code analysis, again, for which you would work to enforce the quality objectives as quality gates within the pipeline. And that would include all the verification objectives you defined with your team at the beginning of your project. No critical vulnerabilities, no, I don't know, whatever you define it. And it breaks the build, of course, if you don't fulfill those requirements. So that's another place within your DevOps workflow to include static code analysis. Using static code analysis this way, it's really a, oops, sorry. Yeah, so It's a way to find and fix integration issues as soon as you can detect them. Continuous integration, you have integration within the world, and that's when you would have integration issues. And having static code analysis within those CI pipelines is a way to detect continuous integration issues as soon as possible. And that's a way also to enforce the quality gates you defined again at the very beginning of your project when you assessed criticity of your software. And finally, you would publish the results. You would have a dashboard for your software quality, so it can be focusing on static code analysis. You can have dashboards for testing. You can have dashboard that manages all the verification tools you are using. And in this dashboard, of course, you would be able to triage the results from the static code analysis, assign new findings from those tools to your peers or to yourself, to focus maybe on critical defects that have been detected, to refine the quality objectives you first decided to implement at the beginning of your project. So a lot of features that are needed to work as a team on your project with the focus on static code analysis and quality objectives. Okay, so using that tool, it's a way for your team to monitor the quality objective trends you have defined and be sure that along the time the number of critical issues is decreasing or at least is constant. You don't want to downgrade the quality of your system. It's also a way to foster team collaboration across the quality of your software. All right. So as you can see, static code analysis can really apply in many stages of your development process. And you will not use all techniques at all stages. You will not focus on the same component at same stages. It's a large variety of possibilities, infinite, some would say. So, just coming back to the meaning of this talk today, it's static code analysis for maintaining quality in software development process. I hope we address that. So let's do summarize. It's all about your software. It's all about your project to use static code analysis. It's about your quality requirements, the criticity of your software, the architecture of your software, your development process. We viewed those points earlier. You could also, we could also consider your team. Is your team experimented? Is it a team of junior developers, a mixed team, all over the world, in some place, 20 people, thousands of people? It helps also to define what kind of static code analysis objective you want to achieve. How long is your project? Do you need to deliver often? Once in a while? Just once? Everything can dictate how you should use static code analysis during your project. And it's all about your software project to implement static code analysis in the best way. So with the criteria we've seen just the previous slide, it's about selecting the right methods that would be relevant for your project. It would be defining the right scope of the analysis at the right stages of your software development workflow. And it would be also used to define your quality objectives. And what I just said for static code analysis would also apply for testing, for example. All this talk, you can replace static code analysis by testing. Or techniques would be different, but that need to analyze your project and your requirements in terms of quality would apply the same way. So, static code analysis is more than just maintaining quality. It's also ensuring that quality never diverges across the time. It's a way to raise the skills of software engineers. Because when you have a warning from static code analysis about buffer overflow, and you get this warning several times, then it will put a seed in the developer's brain, and when the next time he will write an array, he will think more about the potential issue related to buffer overflow, let's say. It's a tool that also helps team to collaborate on results. Is it a false positive? Is it a true stuff? Yeah, let's discuss. Let's consider our code together. It's a way to increase the delivery pace of your software. If you find the issues very early in your development process, like within the IDE, no need to have that long feedback loop until the end of the CI pipeline to fix that very obvious bug that you missed when you introduced it in your IDE. And finally, it's a way also to avoid defects and vulnerability escape into your production environment. So it's really important to apply that kind of techniques along with the testing that I heard a lot at the beginning. So our lives depends on software. And with static analysis, it's a way for you to build a software which we can trust. And that's it.
Thank you. Thank you so much. Thank you, Alexandre, for your interactive talk. Thanks very much. I think we've got several minutes for questions or ideas, comments. So anyone, please raise your hand. We've got one over there, please. Thank you. Feel free to think of your questions. We have some time for a decent Q&A.
Thank you for the talk. The question would be actually for the audience. I wonder how many of you have ever done a formal code proving? Thank you.
So the answer, I guess, was just a few people, not many. What does that mean? Is that good? Is that bad? Is that interesting? Well, what's your take on that?
I meant this was mentioned in the talk as a way of static code analysis, and basically I've done this, but I've never seen this actually happening in the industry, but rather only in academia.
Thank you.
Interesting. It's widely used in the industry, in software critical. Yeah, sure. I mean, in the aerospace, in the automotive industry, when you have the safety critical components, like the airbag, for example, in your car, they are usually verified using a formal analysis to ensure you don't have robustness issues. Sorry? We've seen the answer from the audience. Yeah, it's a quite advanced technique. My own observations. But that's a very good point. I mean, if you don't work on security or safety critical software, maybe it makes no sense to use such kind of tool, because it has a cost in terms of implementing and interacting with these tools. All these tools have a cost, and not in terms of license. I mean, in terms of using them, etc. So that's why, again, assessing criticity of your software is important, because the most critical your software is, the more tools you will try to use as a safety net into the quality of your software to avoid escaping as much as defect as you can.
Perfect, thank you. We've got one more question over there, please.
Hi. I see many tools emerging. I have many ads of tools that are plugins to editors that gives instant feedback to developer and automatically modifies your code based on machine learning algorithms. Do you use one of these tools? Do you find them useful in your work? Would you recommend one?
So I see 2 points in your question. The first one is within the IDE, and of course, those ones are almost mandatory today. It's finding the stuff when you write your code is the most efficient way to, as I said, have them continuing their lives into the integration process. Machine learning, I don't know. It's a kind of hype today. Would you expect machine learning to change your code? I mean, code is not just writing some lines of C or C++. There is a semantic beyond that code. So, I don't know. Do we expect the machine learning to be able to handle that semantic within your code? I don't know.
Thank you. Any more questions or ideas, please? One more over there.
Hi, Pavel here, and I see that Polyspace is actually a tool from MathWorks, yes? So, can you tell me, like, what's the average price of using it? Because that's my question, which arose when I've seen the Polyspace that is already provided by MathWorks, yes?
So, I'm not the sales guy. I'm not talking about price. I can connect you with sales rep and the account manager of Nokia.
Yeah, be brave. Go ahead. One final question. Anyone? Any more? Yeah, one over there.
Thanks. Maybe about the practicality. So I think it was briefly mentioned in your talk, but not explicitly. Do you, in practice, experience different rule set and breadth of static analysis depending on where in the process pipeline it's placed? So, for example, if you have in the editor, you don't want to wait like a minute for the feedback, and when it's in some automated system like continuous delivery, it's not a problem. So does the breadth or rule sets changes with the placement in practice? So what's your experience?
Yeah, that's a very good remark. That's why on the IDE, generally you would focus to kind of, so the scope would be the file, so it can be analyzed very fast by the static code analysis tool. Again, it's all about criticity of your software. You are maybe more willing to wait a couple of minutes to get formal proof of your critical unit, whereas if it's a library that is used for login, and even that you may want to be very careful, knowing the log4j vulnerability. You may want to have very fast feedback in a few seconds, and for that you will eventually reduce the scope of the analysis to maybe coding rules, coding standards, very obvious critical defects. And even in the CI pipeline, you may want to have static code analysis to be fast enough because you have some requirements to have, for, let's say, your pipeline for code review to run within 15 minutes. And if you have such kind of requirements, and that's a very good point, it could be also a way to feed the settings of the static code analysis at various stages if you're in your workflow. You will also define the breadth, the scope of the analysis in terms of files or components, and also in terms of kind of defects you want to focus on.
Lovely, perfect. Thank you so much. Thank you, everyone, for your questions. Alexandre Langenier.
Thank you.